So now that we've explored functions, now we're going to talk about how do we build the equation form of a function from any particular form that we're given. Not necessarily a graph, words, any of those things. We have three different forms of our linear functions. The first way is slope-intercept form. Slope-intercept form is our favorite. Y equals mx plus b. M, of course, was slope. Rise over run. B is our y-intercept. Is the point where x is 0 and we have some sort of coordinate for y. It's where it crosses our y-axis. Point slope form. It's the most useful technique to build linear equations because all you need is a point and a slope. Literally, that's why it's called point slope form. And then the least helpful but fairly common, standard form. We are not going to concern ourselves with standard form when we're trying to build a linear equation because both of these techniques are easier. Say you've got a table and I need the equation that generated this table. The minimum number of points you need is 2, so this is all you need. You could have a table of 100 points. All you got to do is pick 2 of them. First thing we've got to do is find our slope, m, by analyzing how we change from one to another. So from 10 to 19, that's a change of positive 9. From 4 to 7, that's a change of 3. So our slope, which is y over x, the change in y, I should say, over the change in x, that's the Greek letter delta, change. You get 9 over 3, we get 3. Using our point slope form, we're going to write it down exactly as we see it before we plug anything in. Y and x are our variables. They don't get plugged in. x1, y1, and m are all just in place of actual values. We know what m is. It's 3. We have x, we have y, we have minus because that's what's given right here. Now we're going to pick one of these points from our table. Truly doesn't matter which one. Pick the one that looks easier. To me, the top point looks easier. And we're going to place them right here. So y was 10, so we put 10 in for y1. 4 is x, we put it right here. And we now have our slope, or our point slope form, I should say. Pick that purple over here. Point slope form of our linear function. Technically, we have our linear function right here. This is the equation. On our homework that I'm going to ask you to complete, I want you to convert it into slope-intercept form. So we need to get this equation to say y equals. So the first thing we're going to do is we're going to distribute the 3. You get 3x minus 12. No parentheses, so I don't need that. We add 10 to both sides. We get y equals 3x minus 2. There's our equation that gave us this table. Try again with another table. First thing we've got to do is check between our 2 points. From 2 to 14 is 12. From negative 5 to 10 is 15. So our slope is 12 over 15. Always simplify. 3 goes into both of them. Gives us an equation of 4/5. Or a slope of 4/5, I should say. Using point slope form, I need a point and a slope. We have the slope. Now we're going to pick a point. You once again can pick either of the 2 points. For learning purposes, I'm going to pick the top point so you can see what happens when we incorporate a negative. There may come in a time in our equation where you don't get a choice. You have to include a negative. You could have easily have chosen the 10 and the 14 and avoided the negative altogether with this problem. Let's assume it's a problem. Say this one where you can't avoid a negative regardless. So x is at negative 5, so I'm going to put negative 5. Y is at 2, I'm going to put 2. Now I know a lot of you are already like, well, these two negatives, they can make a positive. You're exactly correct. I'm taking it one step at a time so I don't have unnecessary errors. There is our point-slope form of our linear equation. Now I'm going to distribute the 4/5 so I can get this into slope-intercept form, so it says y equals. So I have y minus 2 is equal to 4/5 x. 4 times 5 is 20. 20 divided by 5 is back to being 4. Or quite simply, these 5s cancel out, leaving you with just 4. We add 2 to both sides, and I get 4/5 x plus 6. I'm going to skip the last table equation, but let's say we've got 2 points. We can approach this problem the exact same way as we approach a table problem. So we could record the 2 points side by side in a table and go from there. Here's another way to do it. We talked about it in class. We can use our slope equation. Our slope equation looks like this. y2 minus y1 all over x2 minus x1. So each one of these points, x and y, we just have to choose one of them to be the 2's and ones to be the 1's. I'm going to make this grouping the 2's, this grouping the 1's. When I plug it in, I get 17 minus 1. So I take the y's, put it over the x's, x2 minus x1. And I end up getting 16 over 4, or just 4. Now, I don't know if I'm 100% in love with this equation, because it's a lot of extra work, and we could just put it in a simple t-chart and go, alright, from 1 to 17, that's 16. From 2 to 6, that's 4. We know 16 over 4, therefore it's 4. Either way, the same answer both ways. Y minus y1 equals m x minus x1. Then we're going to pick a point, doesn't matter which one we pick. We have our slope of 4, x minus y minus. In this case, let's pick our smaller point, the 2 and the 1. 1 is the y, 2 is the x. Convert it into our slope-intercept form. We get y minus 1 equals 4x minus 8. Add 1, and we get 4x minus 7. So even if it's in point form, you can convert it into a table and use the same technique that we've been practicing. This over here is called the slope equation. It is just an equation of the table form that we've been using. I have a few examples. We're going to skip them because it's basically the tables. Now from a graph. Same process. We need to find the slope. And this one, we can make it even simpler. We can find our y-intercept directly from the picture. Now, if it's not visually put in the picture, say this line ends up being over here and we don't see where it crosses, then we just have to pick a point and we can solve it the exact same way. Find the slope, we need to find 2 points. Looks like we have a perfect point right there, perfect point right there, perfect point right there. It doesn't matter which one we pick, I have to pick 2 of them. Let's say I pick this one and this one. I can start from either point. I usually like to start with the one that is leftmost, so that's this one. And I go 1, 2, 3, 4, 5. So 5 up, 1 to the right, and there's our slope. It would not have mattered if you started this one. 1, 2, 3, 4, 5, 1, but that would have been a negative 5. And then left 1, they're exactly the same. Okay. So now that we have our slope, we have our y-intercept, it is perfectly at the origin, so it is 0, 0. No sense in using our point slope form, we'll just use our slope-intercept form. Y equals 5x. I don't need the 1 on the bottom. And then it's the second number over here, plus 0. We also don't need the plus 0, so we don't have to include it. Perfectly vertical lines are not functions. Since they're not functions, they don't have linear equations. So this is not going to be a y equals. So this is not a y equals equation. What I look for to try to remember is when you have a diagonal line, this line goes through both the x and the y-axis, so the equation should have an x and a y. Perfectly vertical lines only go through the x-axis, therefore this is an x-only equation. X goes through 1, 2, 3, negative 4, and that is the equation. Horizontal lines, being that they only go through the y-axis, would be y equals equations. Maybe we have one where it's not perfectly on the line. That's okay, we can handle that. M and B. So I'm going to start right here at this perfect. I just have to find another perfect point, and in this case it would be halfway. Doesn't mean I have to include that point. I can find others. For instance, I see one right here. See another one right there. 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 So any of these 2 points, any 2 of these points would work. So let's say we just pick this one and that one. I go up 1, right 2, up 1, right 2. There's our slope. Where we cross the y-axis, we're going to have to do a little bit of estimation. X is 0. And if it was me, I would estimate this as negative 1.5. You could write it as a fraction, negative 3/2 if you so choose. Write our equation. We have 1/2 x minus 1.5. Last thing is, what if it is written from words? If it's written from words, we can approach it the same way. We have to find our slope and everything like that. So with all my spare time, I'm able to read in peace. I am able to finish 51 pages every 2 hours, and I was already on page 30. So the key things that we're looking for is, do we have a starting value? And do we have some sort of rate? Meaning something over something, something every something. So a rate is a fraction. It is, the key words that you should look for a rate is every, per, over. And so when one number is being compared with another number. So I see 51 pages, 2 hours. And that's 2 different numbers being compared. The other thing you're looking for is 2 different units that are being compared. So in this case, pages, hours, IV and DV, what controls what? Does the pages control the hours, or do the hours control the pages? big telltale sign is whichever one would be on the bottom of your fraction. So our rate is 51 over 2. Whatever unit's on the bottom is the IV. Start value. So did we have some sort of starting place? Yep. I started on page 30. Another tail sign of which one is IV and DV. This start value, whatever unit we put right here, has to be DV. Has to be. So that helps you, again, identify IV and DV pretty clearly. So hours and pages. Now we just write our equation. Y equals rate of change, slope, 51 over 2, x, plus our starting value of 30. Let's try another one. My candy bar supply is dwindling, being locked up. I had 23 to start this event, and I am eating 6 bars every 11 days. So again, let's kind of get IV and DV real quick. Here's where I had my starting value. 23 candy bars in this side, so candy bars. That means days is our other one. Y equals 6 over 11x, 6 bars every 11 days, plus 23. But there's something a little bit off on my equation right now. Since I'm eating 6 candy bars, there should be a negative rate of change.